There's the kind of award that no engineer or architect would want to receive. Few years back, this award for the ugliest building in the UK was given to the Walkie skyscraper. This building in this picture, this one. It got its name from how it looks. As for this kind of award, it may not look ugly to some, but the design was badly done as it can create harm to people and things around it, particularly those that are in this side of the walkie-talkie building. There were reports that cars or parts of cars were burnt or melted due to the structure of the building and the design itself. Now, before we discuss how this building caused those damages, we will talk about the other type of curved or spherical mirror. Before Libaran break, we studied plane mirror. Yesterday was convex mirror. Now we will consider the concave mirror. The diagram on your screen shows a concave mirror. The reflecting surface is here. The center of curvature C is around here, and the focus is around there. An imaginary line can be drawn connecting these points and extending it a bit to cover also the object, represented by this orange arrow here. This line is usually called principal axis. We first used this term, principal axis, yesterday when we discussed the convex mirror. Now, imagine a beam of light coming from a faraway source. With that, we can assume that the beam is parallel and the light striking the concave mirror would be these. Okay? Using the law of reflection, that is, angle of incidence equals the angle of reflection, we can extend the light after hitting the surface of the concave mirror like this. I use red so you see clearly which one is reflected rays. This one, this, and this one should be around that. These reflected rays have been drawn because of these tangent lines, tangent to the point where light hits the surface. And at that point, we have the normal. These angles, incidence and reflection, are equal according to the law of reflection. So do this pair of angles here. We have a point of intersection here. What can you say about this point? If you may recall, wave like light carries energy with them. If they meet or converge at a point, then that point receives all the energies from each of these light rays reflected by the concave mirror. Can this idea be used to explain the damages caused by the walkie-talkie building? Okay, I will leave that question for now. Let us discuss that inside the video conference room later after this video. Let us go back to my original diagram here. Just like in the convex mirror yesterday, we will use only few of the infinite number of possible rays from a selected point in the object. For simplicity, we will select this tip of the arrow object and consider incident rays coming from here. One ray could be this. This incident light parallel with the principal axis will be reflected this way, passing through the focus. The incident light passing through the center of curvature will be reflected by the concave mirror through the same path. Alright, it bounces this way. This one from the tip of the arrow object passing through the focus will be reflected parallel with the principal axis. Now let's check these rays using the law of reflection. I'll draw a tangent line to the point where the ray hits the mirror, then a normal line in that. This angle and this angle are equal in magnitude as told by the law. Same goes to this ray. The tangent line, here is the normal. Obviously the angle of incidence is 0, therefore the angle of reflection is also 0 degrees. The incident rays all come from the tip of the arrow object. This means that the intersection of the reflected rays will tell us that the tip of the arrow image is going to be here, this one. And then we draw the complete arrow, and here is your image. In this case or arrangement, we can describe that the image is smaller than the object, is located between the center of curvature and the focus, inverted, as you can see it is upside down, and this time on the same side of the mirror as the object. which really means or implies that bouncing of light happened and therefore should be called a real image. If you will place a screen here, this image can be projected on that and seen by people. Now, what do you think will happen if we are going to move the arrow object here? Would the same set of descriptions still applies? How about if I move the object here or here? If it is here, what kind of image can be formed? These questions will be answered later using the Jamboard, just like yesterday. I created frames with same diagram but different positions of the arrow object. Your task later, kids, are to locate and describe the image formed in each of those cases. Okay, we are now going back to the video conference room, and in that room we are going to discuss the walkie-talkie skyscrapers structural design fail before I give you the link to the Jamboard for your work today.